Continuing on with Module 3, Lesson 9. We're on student page A, page 3. Let me brighten this up a little bit. So this one is on age comparison, which we will see that this uses our proportional reasoning skills. So Mary and her mother have the same birthday, so that's important. So each year they both get a year older on the same day. When they celebrate their birthday this year, Mary will be turning 5 and her mother will be turning 40. So keep in mind that this is this year, because there's going to be a question asked about it later. Compare Mary's age to her mother's age for the next 45 years. Complete the following table. So here we're going to add one, so that means we need to add one here. Here we're going to add another one, so we need to add another one. And here we're going to need to add one, so add one, add one, add one, add one, add one. And you can see that her mom's 35 years older, so you could also 5 plus 35, 6 plus 35, 7 plus 35. So now that we're getting up here, let's just do that. So 15 plus 35 is going to give me 50. 30 plus 35 is going to give me 65 because she's 35 years older. Whoops. We can take this paper clip. Okay, and then 34 plus 35, that will be what, 69? 35 plus 35 will be 70. Wow, random numbers here. 37 plus 35 will be 72. 45 plus 35 will be 80. And 50 plus 35 will be 85. So there are their ages. So every time you have Mary's age, you just add 35 to get to her mom's age. What will the ratio of Mary's age to her mother's age be at this year's birthday party? So I read that and I went, how would I know how old she is this year? And then I went back and went, oh, this year she'll be turning 5. So this is the column we'll be looking at. This is this year. And what will the ratio be? So remember how I said order is important? So Mary must be first, and a ratio is just a fraction, by the way. That's all a ratio is. It's called a comparison of two numbers, and we usually compare those numbers either using a fraction, the column, or the word to, like I showed you on the last page. So Mary is 5 this year. Her mother is 40. So that is the ratio of Mary to her mother. But just like any other fraction, it does have to be simplified. So because they end in 5 and 0, we can divide both by 5. So 1 over 8. So this particular year, the ratio of Mary's age to her mother's age is 1 to 8. Or we could do this. Right? Or write the word 2. That's the least common one. So I'm going to make this smaller so we can get everything in. What will be the ratio of Mary's age to her mother's age at their birthday party 10 years from now? Well, 10 years from now would be 5 plus 10, 15, right? So this would be 10 years from now because you have to add 10 to each of their ages. 5 to 15. So this is 10 years from now. So the ratio, again, it says Mary to her mother. So Mary's 15. Her mother is 50. Again, these end in 5 and 0, which tells me 5 goes into both of these. And so this would be 3 to 10. Or 3 to 10, however you'd like to write it. And order does matter, so Mary has to be first. This is usually how we write it in math. That's why I'm circling it. It's not necessarily the most correct answer. They're all right. When will the ratio of Mary's age to her mother's age be 1 to 2? That means her mother would be twice as old, right? So Mary's 1, her mother's twice as old. So 8 times older, 6 times older, 34 and 34, 68, not quite. Ooh, right there. Twice as old, because 35 times 2 is 70, right? So let's just make a notation there. Twice as old as Mary. 35 times 2, or 35 plus 35 is 70. So when will the ratio be 1 to 2 in how many years? So right now they're 5, so in 30 years. Mary will be half her mother's age. Because remember, 1 to 2 really just means 1 over 2, right? So that's saying, when will Mary be half of her mother? So she's half of her mother's age in 30 years, because we have to add 30 to get down to 35. So in 30 years, Mary will be half her mother's age, or you could say her mother will be twice as old as her. So either one of those are correct. In how many years will Mary's age be more than half of her mother's? So 37 plus 37 is 74. 45 and 45 is 90. 50 and 50. So 36 and 36 would be, or 36 plus 35. 36 plus 35 would give me 71. So she is more than half. So that would be in 31 years, because if 30 years she's half, then in 31 years she's going to be more than half, right? So in 31 years, so if you're not convinced of that, so add 31 to 5, and that gives Mary as 36. Add 31 to 40, this is 72. No, 71, sorry. Okay, so add 31 to 5, you get 36. Add 31 to 40, you get 71. So when I double this, I get 72. So isn't she more than twice her mom? But before that, she's not. Like here, 34 and 34 is 68. So she's less than that. 30 and 30 is 60, so less than half. But after she crosses this halfway point, then she's going to be more than 2 times older than her mom. So this would be in 31 years. So I just added 31 to the 5, and I added 31 to the 40. When I double this, it's bigger than that. So that means she's more than twice her age. So in 31 years, comma, Mary will be more than half her mother's age. Okay, one last one. That's kind of a weird question. I would never put one like that on a test. It's just kind of weird. I like all the other questions, but that one's a little questionable. Okay, is Mary's age proportional to her mother's? So all you have to do is look at this. Does 1/8 equal 3/10? Because that's what proportional means. The two fractions are equal, and 1/8 does not equal 3/10. Do you remember that little trick I showed you? You multiply this way, you get 10. You multiply this way, you get 24. Are those two numbers the same? No. So that means they are not proportional. Why did I pick those? Because we already had them done. I could have done them with any numbers, but those two are done. So proportional, as I showed you earlier, means that A over B equals C over D. And since 1/8 does not equal 3/10, then we would say they are not proportional. And remember, we can test fractions by cross multiplying. This is 10. This is 24. If these two numbers are not the same, these fractions are not equal. So Mary's age is not proportional to her mother's age. Do you remember back when we were doing additive reasoning and multiplicative? Proportional is multiplicative, and that's not what age is. Age, each year you add. When I add 10 to Mary's age, I add 10 to her mom's age. So it's additive reasoning. That's why it's not proportional. So Mary's age is not proportional to her mother's age. Every year you compared their two ages, you would get different fractions that are not equal. So just show this work here to show why. That's 10. This is 24. They're not equal. Therefore, they're not proportional. So an example of equal would be like 1/8 and let's say 3/24. Going this way, I get 24. Going this way, I get 24. See how those are the same? So then I'd say, yes, they are proportional. They're equal, but these are not. Okay, so we have about 2.5 minutes. So let's go ahead and start on the next side. And we do have a couple like this on the test. So this would be a really good page to study. Let's just highlight these three. I think the very last test question is one about gallons and miles. Okay, so I'm going to make it big now. Everybody got all three highlighted? Okay, so these are unit rates. We want to know how much one bottle costs. So, line up my pages here. If 6 bottles cost $3.75, how much would 2 bottles cost? So do you see that this is begging you to set up a proportion? And how you can tell is bottles cost. Bottles cost. When they repeat the same information twice, that tells you to set up a proportion. Miles, gallons. Miles, gallons. Miles. Oh my gosh, this is going to drive me crazy. Sorry. And then the last one is miles, hours. Miles, hours. So that tells you to immediately go to your paper and write what you're comparing. Keep it in the same order. So I'm comparing bottles of soda to the cost in dollars. Remember how I said on the first page, always label them, because that way when you find your answer at the end, you'll know what to label it. So then you set your two fractions up and you start filling in. So bottles would be 6. The 6 bottles cost